Recording in progress.
Yeah, comes on everyone. Let's start off. There. So this was the last thing that we're doing. What is vertically up, vertically down? So last class we are doing things for moving horizontally. Now we will see things when they start going up and down. Others, do keep your cams on. So consider a particle is projected up with speed u. Vertically. So if you're throwing something with u vertically upward, it goes up and then comes back again. Actually, this happens on a same line, but for you to understand, I'm drawing it little to the side. So when you reach the topmost point, momentarily you'll come to rest. So this point is called Hmax. Hmax is your maximum distance from the ground level or from the point of projection. And acceleration is Ay is equal to g. Look at the meaning of Ay, acceleration in the y direction. That is the meaning of A subscript y. Ay is equal to g. So Hmax is your maximum height from point of projection. Ay is your acceleration in y direction. If I write Ax, then it will be acceleration in x direction. At Hmax, when you reach the highest point, the vertical component of velocity becomes 0. So before turning back, momentarily, you will just come to rest. There, so I can use my kinematics equation. So we have the data here. V square minus u square is equal to 2as. Remember, up is positive, down is negative. At the Hmax, your velocity is 0, initial speed is u square. 2, the gravity is downward, so minus z, and s is Hmax. There, we get a formula Hmax is equal to u square by 2g. Similarly, if I use the formula V is equal to u plus at, P is 0, this is u, A is minus g, this is called time of ascent. We get time of ascent is equal to u by g. So time of ascent is the time taken to reach the maximum height. Remember, all these are valid only because the g was constant. If g is changing, we have to integrate again. Right? So this way, and then similarly, a better way of writing would be this. I would prefer writing like this. H max will be u y square, the vertical component square by 2ay. This is a better formula because later on when we do two-dimensional, right, the height depends only on the vertical velocity. So ui is your initial vertical velocity. This is a better way of writing, but yeah. Similarly, time of ascent also will be uy by ay. So just keep this in mind. When we use in 2D, this will be useful. So time of ascent is the time taken to reach h max. H max is u square by 2g. Any doubts on this page?
Sir, in vertical motion, do we have to study uh, like when the gravitation, acceleration is changing?
We will study, na?
So that at that point also we'll study the vertical motion when the g is
Yeah,
changing.
yeah,
Okay.
we'll do now. Don't worry, it will come. Right? So then we define something called time of flight. The terminologies are important. The formulas might vary depending on the situation. So TF. So the time of flight is the total time it is in the air. So when you throw this with you go up, and if you come back to the same level, so if you come back to the same level, then the displacement is 0. So we use the equation S is ut plus half at square. Your displacement is 0 since it's back to the same point. This is u, t, gravity is minus g. This will be time of flight square. We get time of flight is 2u by g. Then we also define something called time of descent. This is the time taken to go from Hmax to ground. So time of flight is simply time of ascent plus time of descent. I can just combine them. That will be the total time. So time of flight is 2u by g, time of descent is u by g, and this will be your time of descent. But be careful, these things are a little special. These are not valid every time. If you take a case like this, these formulas what you derived are not valid if you throw from a buildings. If you throw from buildings like this, the time of flight and the values are not valid. So the formulas are not valid for these cases. So time of flight 2u by g and time of descent u by g are valid only if the body comes to the same level of projection. Whatever height you threw, it should come back to the same level. But when you throw from a building, you're throwing from here, but you're going below the building. So that is not valid. We can't use this formula. Displacement won't be 0. Valid. We will see how to do those also. What happens if you throw from a building? That would be the next case. Comes back to same level of projection. You don't have that problem in Hmax and time of ascent. Huh? These things doesn't matter, but you can throw from a building. These things are still valid. But time of flight and time of descent, you'll have an issue. If you don't come back to the same level, you can't use these formulas. They are the main 4 quantities there. All clear with this? Any doubts? Anyone not clear with anything, please ask. Clear, Shreyansh? Satyasha? Kartika? Advai? Great. So just let me write the more general things. So if you projected a particle with speed u, it goes up and comes down. So at any time, if your height is y, the y coordinate, at some time your velocity is vy, the 3 equations of kinematics will become like this. V is u plus at. This becomes v is equal to u minus gt because a is minus g. S is your ut plus half at square. S becomes your y coordinate. This becomes ut and a becomes minus g, half gt square. V square minus u square is 2as. This will become v square minus u square. This will be a is minus 2gy. This is how the equation should look in vertical direction. You just replace a with minus j and the displacement with y coordinate. H max is u square by 2g. Time of ascent is u by g. Time of flight is 2u by g. Time of descent is u by g. These two are valid if you come to the same level. There, these are all the formulas we derived. Clear with this? Param, clear? Let's see a few questions on this. Clear, na? Siddesh, Tanishka, Yashvi, Utsa. Great. Let's see a question. We have a particle projected with u is equal to 20 meters per second. G is 10 meters per second square. First question. H max, time of flight. Second question. Time when it reaches H max by 2. Third, speed at H max by 3. Distance traveled in 3/4 of time of flight. Let's get them all. Yeah, first one is easy. Get the D part, I'm more interested in that. Solve everything. Yeah. So particle is projected at 20 meters per second, gravity is 10. So H max time of flight, then time when it reaches half of H max, speed when it reaches 1/3 of H max, and the distance traveled in 3/4 of time of flight. Nay, Shreyans, that is wrong. Others need to keep your cams on. Shaunak, Sudiksha, cams on. Get me the answer for B and D. I'm more interested in that. Remaining, there's no need to type. If you got an answer for B and D, type. A is okay. A is easy. So it's just formula substitution. Nay, Vanshika. That's not the answer for D. D5. Nay, you got too much, I think. Nay, I think you got too much. Nay, that is wrong. Param, any answers for B and D? Try.
It's all easy.
Yeah. Try. You got an answer, type in the chat box. Speed you got. Nay, Arya, you went way beyond. We need people like you in NASA and ISRO. You get sent to moon directly. बहुत ज्यादा आ गया तुझे. I hope everyone got the first one. So first one was easy.
But we will have two answers, right?
Yeah, type both of them then. U square by 2g, this is 20 meters. Time of flight was 2u by g, this was 4 seconds. Then, so A, there is nothing, substitute the formulas. No, get BCD. Param, that is right. Ishman, right. Shriyan's right. Got the time part right. Get me C and D. Got an answer? You can type in the chat box to the
So
co-host here.
it's like 3 by 4 tx second or like for the entire time?
3/4 of a time of flight. No, I said distance traveled in 3/4 of time of flight. Bus. I didn't say
Okay.
3/4 second. ऐसा नहीं बोला मैंने. हाँ, Samyak, there will be two answers for B part. Quadratic है ना? नहीं, Karthika, that's not the answer. I keep telling you, you hear the word distance, have some fear. 20 by root 3. So look at the B part. Find the time when it reaches half of H max. So H max is how much? 20 meters. So indirectly, you're telling me, so the displacement is 10 meters, half of H max. Your speed was 20 meters per second. Acceleration was minus 10, and you want to find time. So there you can clearly see the equation is S is ut plus half at square. Substitute 10, 20, t minus 5t square. This will be t square minus 4t plus 2. Solve this, we'll get t is equal to 4 plus or minus root over 16 minus 4 into 2 by 2. That will be 2 plus or minus 2. We get two answers. Right, Shriyansh? You got the answer for distance. Nee, Aditi, you got something else.
But could you show the question again?
Yeah. 2 plus or minus root 2. There, have a look at the question. Right, Samyak. Right, Ishman. Arya, got it. I think you can all type in that main chat in the box. I don't know. Individually, it is coming a little messed up. It's stupid. You Zoom now. They shouldn't have changed anything. I have to revert back. I don't know how. Anyway, so why are we getting two answers? Because what did I ask you? I said find the time when you reach a half of H max. I didn't tell you which one exactly. There are two times that happens. One while going up, one while going down, isn't it? The question was simply find the time when you reach H max by 2. So this time will be the smaller time, 2 minus root 2. And this will be the other time, 2 plus root 2. So there are two times when you reach 10 meters. That's where the answer you're getting to. H max by 2 is displacement, right? What is displacement? Initial to final position. 10 meters, right? The total height was 20. H max was 20. Half of it was 10 meters. S is displacement. Whether you go up or down, the displacement is that only. Right, Vanchika? Confused. You can just ask, unmute and ask, what is your confusion?
Or means H max is the total distance.
No, H max is simply the maximum height. So this is H max, which is 20 meters, isn't it?
Yes.
If I ask you what is your height of the building, what will you say? Let's say if it's 50 meters, height of the building is 50 meters, right? That's it. Right, Param. Let's see. Kartika, that is still wrong. What about the speed? V square minus U square is 2s. So V square, U square is 20 square, 2 minus 10. And you said H max is how much? 1/3 of H max. That is 20 by 3. So we get V square is 400 minus 400 by 3. Therefore, V is equal to, how much is this? 22 by 3. It's a root over 2 by 3 meters per second. Clear? Yeah. What about the D part? D is a good one. If I had to ask you, that will be a mains level question at D part. Remaining are fine. The question was distance traveled in 3/4 of a time of flight. So that is 3/4 time of flight. So that will be 3 seconds. Now try to understand something here. If you try to use the formula directly, S is equal to ut plus half at square, you will get S is equal to 20 into 3 plus half into minus 10 into 3 square. This would be 15 meters. Now S is displacement. This is not a distance. So what this thing is simply trying to tell you is you have gone up and then you have come back at t is equal to 3 seconds, because see, at t is equal to 2 seconds, you have already reached h max. So at t is equal to 3 seconds, you already started coming down. So from the ground level, you are at a height of 15 meters. And we know the total height was 20 meters. That means this particle has traveled till h max in 2 seconds, 20 meters. Then in the 2 to 3 seconds, it came down 5 meters. So the total distance is 25 meters. Is that clear, everyone? The question was distance traveled. Displacement is still 15 meters. And how do you know it is coming down? T is equal to 3 is greater than T is equal to 2. When T is equal to 2 is H max. You have already crossed H max and you have come down. All clear with this? Easy? Got this? So be careful. Whenever I ask you distance, you have to draw the path. Any doubts on this?
Sir, how did you find the distance in each case?
Just see, Nare. This is 20, this is 5. What is there to see?
No,
H max is 20 and that is 5. Advai?
how did you get that 5 exactly?
20 minus 15 is 5, Ray.
And 15.
S is ut plus half at square is 15.
Oh, okay, sir.
Yeah. So yeah, listen when I'm explaining. So if you're asking me 20 minus 15, how will I explain you? Next thing. So we have a particle here projected with speed u. Let this be the origin 0, 0, and let this be some coordinates d, 0. So this guy will keep going straight. So as this is flying up and down, find the position vector r bar as function of time t. Find d mod r by dt as function of time t. Exactly what I'm asking you. See, after some time, the particle will be somewhere here. This is your r bar, isn't it? As the particle is going up, your r bar is changing continuously. R bar is a position vector from your origin. So find r bar and find d mod r by dt. If you guys remember, we had a discussion on what is d mod r by dt. We had a very extensive discussion. We talked about what is exactly that. So hope you remember. Mod r bar cut differential. Let's get them. Yeah, the position vector is easy. नहीं यार, yeah, that is wrong. Gravity है ना, God. Gravity is there. You're throwing it vertically. Yeah, that is fine. Get me the second one. D mod r by dt. That is what I'm more keen on. Position vector is fine. Samyak, position vector is fine. Yeah, Utsa, Shman, Shriyansh. Yeah, all of you getting the position vector right. I want d mod r by dt. I'm more keen on that. Get me the answer for that. Dwayne got the position vector. Yeah, please try. Great, Aditya. See the position vector part. So after time t, you will reach some height here, y coordinate, which is what? Ut minus half gt square. So this coordinate will be d comma y. Therefore, your position vector r bar will be di cap plus ut minus half gt square j cap. Now what I asked you is mod r bar. So mod r bar will be root over, this is complex, d square ut minus half gt square ka whole square. This is your mod r bar. So what I asked you is to find for this d mod r by dt. You can do this, you will get it. It's quite long, but there's a much faster way to do this. If you differentiate this, what do you get? 1 by root over d square plus ut minus half gt square ka whole square. Then differentiate whatever is inside, chain rule. This will be 0.
You multiply half also.
Yeah, there's an half also. This is bad. And then differentiate whatever is inside. That will be 0 plus that will be again a chain rule inside. 2 into ut minus half gt square. Then differentiate whatever is inside. That will be u minus gt. You can check it out. So the 2 will cancel. You'll get ut minus half gt square. U minus gt by d square plus ut minus half gt square. Quite big. But if you actually see this is nothing but ut minus half gt square is your y coordinate. U minus gt is your velocity. And that denominator is mod r bar. Isn't it? That is y v by mod r bar. And from here, if you look at the geometrically, so if this is y and this is r, right? If you take this angle to be theta, cos theta will be y by r. So this guy is actually v cos theta, where y by r is nothing but cos theta. So theta is the angle, this angle. This we just used brute force and we differentiated it. But remember, I taught you a mathematical reason, like exactly what does it mean? Anyone remembers what exactly d mod r by dt means? We have done this in just chapter only. We didn't do it in some other different chapter. See,
Rate of change of position vector.
no,
Magnitude of
it's not rate
position.
of rate of change of magnitude of position vector there. Where do we do this? Here, this question. See, question 9. This is the first time we encountered something called d mod r by dt and d mod r by this thing here. And this was the explanation I gave. If you have an r bar vector and if you have a velocity vector, the velocity vector has two components, a u cos theta and a u sin theta. The u cos theta is trying to increase the length of the vector and u sin theta is trying to rotate the vector. So when you say d mod r by dt, just try to read the statement. What is mod r? Magnitude of the vector. So I'm asking you to find a rate of change of length of magnitude of the vector. So now you tell me which velocity component is responsible for changing the length of the vector, u cos theta. So d mod r by dt is u cos theta, where theta is the angle between r bar and the velocity vector. And that's what we got again here. Same thing. After doing all the differentiation, you still ended up with v cos theta. So if this thing they ask in an exam, the fastest way to do is this. So at this instant, this is your velocity v, which is u minus gt. This is your r bar, the position vector. So if you take this angle to be theta, this v will have two components, v cos theta and v sin theta. So here v cos theta is responsible for changing the length of the vector. So if this is mod r bar, the one who increases mod r bar is v cos theta. V cos theta is responsible for changing length of the vector. Be careful, d mod r by dt and this thing are completely different things. If I write dr by dt ka mod, this is mod v bar, this is speed. If I ask you d mod r by dt, this is not speed, this is something else. This is rate of change of length of the vector. Which is nothing but v cos theta. If that is theta, this is theta. This distance is d, and this distance is y. So I can simply write cos theta is equal to y by d. I know everything. This is a much faster way of doing it. Meaning, yeah, this is not wrong, but yeah, differentiation. Luckily here it's still 1D, so you can do this. But later on when we see in 2D, you will get stuck. But is everyone clear what is d mod r by dt? So dr by dt ka mod and d mod r by dt not same. Haan, yeah.
Sir, but in an actual question, how are we supposed to find an angle?
Find the angle. What is the problem?
Like it's changing, like at all
Let it
times.
change, na? So fine. Na? So they'll give you answer
So,
in terms of time.
so
What
we'll
is the
have to
problem?
find using the normal method only, right?
Why will you do that? Can't you find y in terms of time and just substitute there? You can skip integration, right?
Oh.
Differentiation. See, don't worry about how they'll ask. They'll ask anything. They'll say at time t is equal to 2 seconds. Then kya karoge? You don't worry about that thing. Got the concept? Yeah. All clear with this thing. You should definitely, go back and check out this thing. We did even more variations of this. This was a pretty good question, 10th one, if you see. Mod of dr by dt, d mod r by dt, mod of dv by dt, d mod v by dt, integral v dt ka mod, integral mod v dt. So putting that modulus inside and outside will change the whole equation. So definitely go back, revise the notes. We have done this. This is question 10, same chapter. Next one. Before going ahead, a little intro about this infinite GP. We have done this before, but in case someone don't remember or don't know this concept, if you have infinite terms, a plus ar power 1 plus ar square, so on till infinity. This is an infinite GP. The summation is given by a by 1 minus r for r less than 1. A is your first term. R is your multiplying factor, which is the nth term by n minus 1th term. Example, if someone gives you a sequence like this, 2 by 3 plus 2 by 3 square plus 2 by 3 cube, and so on till infinity. The sum of these infinite terms will be a by 1 minus r. A is your first term. Multiplying factor is also 2 by 3. This will be 2 by 3 by 1 by 3, which is 2. In case you forgot this thing, you should refer the basic max notes. We have done this. There, this is your formula. You can just remember this in case you don't know about this. A by 1 minus r. All clear with this? Let's see a question. We have a particle projected with speed u. The particle goes up, comes back, falls on the ground, it bounces again, falls on the ground, bounces again, falls on the ground, and so on. Technically speaking, it should be on the same line, but for you to understand, I'm drawing a little to the side. So this particle will just keep hitting the ground non-stop and bouncing. A particle is projected vertically with you. After hitting the ground, its speed becomes 5/6 of the previous speed. So if you hit with u, your speed becomes 5/6 u. So whatever was the previous speed, it becomes 5/6 of that. Find total distance, total time, and average speed. And I'll just ask you average speed if it's an exam. And just to give you a little idea if you're confused, so if you go with speed u, you come back and hit the ground, your speed will become 5/6 u. Now you'll go lesser height and you'll come back. Now your speed will become 5/6 ka 5/6 u. So 5/6 square u. So on. So every time your speed becomes 5/6 ka factor. Let's get this, everyone. Find the total distance, total time, and the average speed. Answer comes in terms of u, and you can leave it in terms of g. Huh? Don't substitute g is equal to 10. Leave the answer in g. नहीं आ रही है, that is wrong. No, you might be right actually. No, that T. What is TD? Time of total time? Kya? Distance. Okay, that
No,
is
sir,
distance.
total distance.
No, that is wrong. Siddesh, you got it. Ishman, you goofed up somewhere. Arya, you also goofed up. Try. Others, get me the total distance, the total time, and the average speed. Average speed is what? Total distance by total time. So if you know the first two, you'll get the third one. Total time. Right, Samyak. Keep going. Answers, everyone. If you got something, you should answer. Advai, answers. Please try. Let's see. Arya, you got it right. Right, Samyak, you got the time. Let's see the first one, everyone. I think, Ishman, the mistake you did, you didn't count the distance double. Up and down has to be counted, na? Right, Arya, you got answers. So when you project with speed, you look at this thing. You'll go up, you will come down. So how much are you traveling? You're traveling h max while going up and h max while coming down. And h is equal to u square by 2g. So second time when you collide with the ground, your speed has become 5u by 6. So h is proportional to u square. Now your height will become how much? 25 by 36 h, isn't it? 5 by 6 ka square. So maybe I'll write like that for you. 5 by 6 square per h. Second time when you collide with the ground, your speed becomes 5 by 6 square ka u. So this time your height will become 5 by 6 whole square ka square. So that is 5 by 6 power 4 into h. You're getting the height is becoming like this. What about the time of flight? Time of flight is 2u by g. So this is proportional to u. So if you say this time is t, then this time will be 5 by 6t. This time will be 5 by 6 square t, and so on. So time and distance of factors are going like this. So what's the distance traveled? Remember, distance up and down, you have to count it 2 times. So it is 2 times h plus 5 by 6 square ka h plus 5 by 6 whole power 4 ka h, and so on till infinity. Take out the h common. You will get a sequence there. You can see this is 5 by 6 square, 5 by 6 whole power 4, and so on till infinity. So here a is 1, and the multiplying factor is 5 by 6 ka square. So every time it is getting multiplied by 25 by 36. The formula is a by 1 minus r. That is 2h, a is 1, and this is 1 minus 25 by 36. That is 72h by 11. And h is u square by 2g. I'll substitute that. So I think then I'll get 36h by 36 u square by g11, whatever you guys got. That's your distance, everyone. Similarly, I can do the same thing for time. Time will be t plus 5 by 6t plus 5 by 6 ka square t, and so on till infinity. Take out t common, you'll get a sequence there. That will be 1 by 1 minus 5 by 6. That would be 60. T is nothing but 2u by g, so that is 12u by g. That's your time of flight. What is average speed? Total distance by total time. Total distance is 36 u square by 11g. What is the total time? 12u by g. Gg cancels, 12 goes off. That will be 3u by 11. Check your answer, everyone. Right, Aditi, you got the time part. 6u square by g, distance part, that you goofed up. Right. Have a look at this. So there, this is how your infinite GP comes. When we did in the beginning, I told you, right? It is just a tool. So you should know this formula. Physics mein this thing comes a lot. A by 1 minus r. In max, they will teach you progressions and everything. Ha, Param?
Yes, sir, I get what we did for the sake of the question, but is it actually right to assume it to be an infinite GP because it will come to rest at some point?
So yeah, it will come to infinity at eventually, right? Everything that you're doing is theoretical only. So you didn't have a problem when I said there's no air resistance. You're okay with that. Right? You didn't have a problem with variation of Earth and all. So there are certain assumptions. So we started with the whole assumption. So yeah, we study theoretical cases. Unfortunately, real life may, if you actually try to study real life, we will go mad. The kind of equations you'll get, you'll not be able to handle it. You will see. I'll just change few things and you'll see how tough it goes. All clear with this? Still a decent question. If you still ask me, it is still a mains level one. It's a good one. But any doubts on this? There's nothing there. It is just brute force. Matlab, you got the height, you just substitute there and solve. We just combined infinite GP with this. All clear? Aditi, got your mistake? Shriyansh? Srihari? Vanshika? Siddesh, Shreyan? Perfect. Next one. A particle is projected with you, goes up and comes down, gravity is. Now, you observed a particle is projected with speed u. Again, remember the diagram should be like this single line, but you won't understand. So I'm drawing it with a little gap. So it's not a projectile motion or anything. It is observed that distance traveled fifth second, there are 5 seconds, fifth second and sixth second are equal. Find H max. U is not given. What did you do actually? Oh, you did it. No, you got it right. Right. You're right. You're right, Arya. Try. Others keep trying. I'll give you a minute. It's a good one. It's a pretty good mains level question. Matlab. You have to think there is. Right, Samyak. What is the catch? Right, Siddesh. Listen, see. Let's see, like what is happening in the picture. What is fifth second? Fifth second is 4 to 5 and 5 to 6. Now, let's say we have two options, okay? Let's say if the particle is going up and assume t is equal to 4 occurs here and t is equal to 5 occurs here and t is equal to 6 occurs here. So this is your fifth second, 4 to 5. This is your sixth second, 5 to 6. Suppose if this was the scenario, when the particle is going up, what happens to the speed? Speed is decreasing. That means you will travel less and less distance, isn't it? As you go higher and higher, you're going slower and slower. So if the particle is going up, we will get the distance traveled in the 5th second will be greater than distance traveled in the 6th second. Agreed? S5 is greater than S6. You can just finish off mathematically also, but let's see interpretation how to do it. So matlab, this can't happen. If the particle is going up, you can never have S5 is equal to S6. Let's say, suppose if the particle is coming down, let's say this is t is equal to 4, and let's say this is t is equal to 5, and that this is t is equal to 6. So while coming down, speed increases. That means you cover more distance as you come down. In this scenario, S6 will be greater than S5. Now, tell me one thing, meaning the case which I asked you can't happen while going up, can't happen while coming down, then there's only one possibility left. What do you guys think? You're getting how we are interpreting it? This can't happen while going up, this can't happen while coming down. Then the only thing left is this must have happened while partially you're going up and partially coming up. That means t is equal to 4 must have been here, t is equal to 5 must have been here, and t is equal to 6 must have been here. It must have been symmetrical on both the sides. Is that making sense? If you can't go up, if you can't come down, that means you're going up and coming down. That is the only possibility left. That means at h max, the time is 5 seconds. Is this making sense? So this is the only possibility where it is symmetrical on both the sides, where S5 is equal to S6. So indirectly, you gave me the time of ascent or to reach match max is 5 seconds. Time of ascent is u by g. Therefore, u is 50 meters per second. So this happens only for 50 meters per second. And h max is u square by 2g. 125 meters. All clear with this? You could have actually used the ascent formula. I think we would have still got the same thing. But having an interpretation is nice, important. Any doubts on this? Easy? Yeah, it looks easy after explaining, but getting that starting part is important. Next one. Next one. This is a good one, right? If it's an advanced question, I'll ask you this maybe at this level at least. So we have a weird planet. Where on this planet, right, the gravity becomes, so for every 10 meters, the gravity gets messed up. So for the first 10 meters, gravity is g. For the second 10 meters, gravity is g by 2. For the next 10 meters, gravity is g by 4. Next 10 meters, gravity is g by 8. And yeah, sequence, it goes on. I can write this thing as g by 2 square, g by 2 cube. So on. This is going till infinity, never ending. Now what you did, you projected a particle with speed u here in this kind of a planet. Now let's not worry about can this planet exist, can it be there? It exists on my paper, so it is there. For every 10 meters, gravity becomes half. The first question, if your speed of projection u is 15 meters per second, find h max. Second question, this would be a good one. Find the minimum speed so that the particle never comes back. So there's a name for this kind of a speed. This is called escape velocity. Escape velocity is the minimum speed required to escape a planet. Again, listen to the question. We have a weird planet here where for every 10 meters, the gravity becomes half. So for the first 10 meters, gravity is g. Second 10 meters, gravity is g by 2, g by 4, g by 8, and so on till infinity. This is never ending. So first question, if the speed is 15 meters per second, find h max. Second question, with what speed should I throw so that this particle never comes back? It just goes away and it never comes back. Let's get this. Let's get the first part. Now be careful, you can't use the formula u square by 2g directly because gravity is changing. But so how do we proceed? Think. You got 2 minutes for the first part. Kartika, question is clear? Yeah, let's give it a try. Utsa, can't see you, right? Adjust your camera. Yeah. Yashvi, Utsa, can't see you guys. Sudiksha, do adjust your cameras a bit. Make sure your faces are visible on the screen. Samyak, you got the first one right. Get the second one. We have one answer. Ishman, Yaria. Yeah, you all got it. Get the second part. Fine. Fed the first part, everyone. You got a minute more for the first one. Right, Utsa, you got it. Right, Siddesh, you got it. नहीं हो गया. That's not the answer. Let's see the first part. Now see, yeah, I agree. You can't use the formula completely, but again, you can use the formula as long as g is constant, isn't it? So let's do this way. That statement is right. You can't use the formula for the entire motion, but I can use it for the first 10 meters. So for the first 10 meters, the gravity is g. Let's do like this. So let the speed be here. When it reaches the first boundary here, let the speed be v1. So what is the speed here? So v1 square minus u square is 2as, so that is 2 minus g, and this is 10 meters. So u is given 15. So you end up with 225 minus 200. So this is 25. So v1 is 5 meters per second. So when you reach the first boundary, you are reaching with a speed of 5 meters per second. So you have to check, are you crossing the boundary or not? Then, so when you do for the second boundary, the gravity has become g by 2, which is 5 meters per second. So again, you can use the equations, but remember this time the gravity is 5. So we need to check, like this is 10 meters. So this is for the first boundary. For the second boundary, right, let's check what is h max. H max will be v1 square by 2 gravity, which is ay, which is 25 by 2 when the gravity has become 5. How much is this? 2.5 meters. So this is less than 10 meters, right? This guy is less than 10 meters. That means it is going to turn back here. So there's no need to solve again. So you have to, after every boundary, you need to check whether you're exceeding 10 meters or not. Since this is less than 10 meters, you don't go to the third boundary. Question got over there. It turns back. It doesn't cross the third boundary. There. So you traveled 10 meters and then you travel 2.5 meters and you're back.
But wouldn't this be time consuming for larger values of u?
Yeah, we will see how to do that also. But did you get this? Did you get this?
Yeah, I got this.
Yeah, then fine. Should have answered this, no? Did you answer for this?
Also.
Nah, I should have answered for this. Then we could have talked about the n boundaries and all. Which
I
comes
was
next?
trying to get it without some
Yeah. So this is 12.5 meters. Let's see. What about the second part? What is asking is fair enough. What if it is an n boundaries? We'll see next. How to do for the infinity thing. Now listen. So let's do like this. So let's say when you reach the first boundary, velocity is v1. Let you reach the second boundary, velocity is v2 and v3 and so on, right? So now when you write the equations for the first boundary, v1 square is the final velocity, u square is your initial velocity. So v1 square minus u square, this is gravity g, this is g by 2, this is g by 2 square and so on. So this will be, listen carefully, this is 2 minus g, 10 meters. This is for the first boundary. For the second boundary, v1 is the initial velocity, v2 is the final velocity. Agreed? The final velocity of one boundary will be the initial velocity for the next boundary. So this will be v2 square minus v1 square. This will be 2 minus g by 2 into 10. For the third boundary, v2 will be the initial velocity, v3 will be final. v3 square minus v2 square is equal to 2 into minus g by 2 square into 10. And so on. If you keep doing this, you'll end up with vn square minus vn minus 1 square is equal to 2 minus g by 2 power n minus 1 into 10. These kind of functions are called telescopic functions. If you have studied in max somewhere. And the best thing about these functions, if you add all of them, If you add all of them, what do you get? You will notice this v1 goes off, v2 goes off, v3 goes off, this goes off. You're stuck with vn square minus u square. You can take out the 2g common, so that will be minus 20g common. You'll end up with 1 plus 1 by 2 plus 1 by 2 square, so on till 1 by 2 power n minus 1. There, Param, that is where you get it from. Now, when you want to stop, you put vn 0, then you get an n ka term there. So that is the boundary which you have to study. But our question is still not over. But so far, is it clear, everyone? Arya, bolo na.
Sir, but we are talking about infinity here. Right?
आता है ना, we'll reach there ना. Any doubt till here? अभी n आ गया तो infinity भी आ जाएगा. Clear till here? Now, so this is your formula there. Now, if you say you're going till infinity, that means your nth boundary is the infinite region. Since it goes to infinity, that means your n ka value will tend to infinity. So your formula becomes v infinity square minus u square will be minus 200. Now this will become an infinite GP. The previous one is the geometric progression. You have a formula for that also. You will not need it normally. A into r power n minus 1 by r minus 1 and all that stuff. There, that's how your formula becomes. V infinity square minus u square is minus 200 into this. I'll show that. So this will be v infinity square will be u square minus 200. So this will be 1 plus 1 by 2 plus 1 by 2 square. So on till infinity. This a is equal to 1 and r is equal to half. So the sum of infinite terms will be a by 1 minus r. That will be 1 by 1 minus half. That will be 2. So you get V infinity square will be U square minus 200 into 2. So V infinity square is U square minus 400. Now you said it never stops. It never stops, meaning the V infinity must be always greater than or equal to 0. This is the velocity at the infinite boundary. Remember, infinite is not a number, means you'll never reach there. Since it never stops, velocity can never be, it can be equal to 0 also because you never reach infinity. Since it never stops, velocity at infinity must be greater than or equal to 0. This turns out to be u must be greater than or equal to root over 400, which is 20 meters per second. Therefore, your minimum speed is 20 meters per second. So if you give exactly 20 meters per second, you'll go to infinity. But infinity is not a point, meaning you will never stop. Anything more than 20 also, you're fine. Is this clear, everyone? Do have a look at this function. So main idea is this: when you add them, they will cancel. This technique is important. It does come few times. Arya.
Sir, is this how we calculate the escape velocity of Earth?
नहीं, अर्थ में gravity ऐसा change नहीं होगा रे. I just give some
There will
arbitrary
be a change
functions.
in gravity, right?
There'll be change in gravity.
So do we take the rotation of in
We'll see
account,
now.
or
When I
we just
teach
do
you
it like
gravitation,
this?
you will learn. When I teach you gravitation, you will learn. So have patience. But this is clear. You guys have to have some patience. There are a lot of things I know when you are curious, but we have to go step by step. You'll see when it comes to gravitation, we have a full chapter for that. This is nothing. You will die there. This is clear. Any doubts on this? Go take a small break. Come back by 9:44. Any doubts so far? Anything you're not clear? Okay, come back in 5 minutes. Let's start off. So let's say the gravity is not constant. So particle is projected with speed u, and let's say again another weird planet, the gravity is given by minus g naught y. Particle is projected vertically with speed u. The acceleration due to gravity minus indicates downward direction. A is given by minus g naught y. G naught is some constant. Y is the y coordinate, or y is the height from the ground. Again, hypothetical case. Meaning, look at the meaning of this. At the ground level, y is 0. So what is the gravity? Is 0. But as you go higher, the gravity increases. The more higher you go, the more the gravity. In real life, it is the reverse. It actually decreases. But this is a case where the gravity is increasing with height. One thing is clear: you can't use your kinematics equations. Nothing is valid because A is changing. Find h max and time of ascent. Let's get this. Answer comes in terms of u, g naught, and yeah. So instead of your regular gravity, we have a gravity which is increasing with height. The higher you go, the more the gravity. Find h max and find time of ascent. How do we even start? Others, you need to keep your cams on, Shaunak, Shreyan, or else you'll be removed from the classroom. Think, take a minute, then I'll give you the mathematical form, then maybe you can do it. But first, you take a minute and figure out. Root 2u by g naught. What is that? H max. Let's see. Listen. So first of all, you have to go back to the basics. Do you guys remember how we derived the whole thing? We took acceleration is equal to v dv by dx, and then we integrated this. So you have to go back to the derivation. You can't use the three equations. You go back to the derivation. So first thing, the acceleration. We have a is equal to minus g naught into y. So what is acceleration equal to? V dv by dy. I can use dv by dt or v dv by dy. I'll use dy because there's a y here. If a is given in terms of y, use v d naught by dy. So shifted that side, this will be v dv minus g naught y dy. Integrate on both sides. When your initial position was 0, velocity was u. When your height is y, your velocity will be v. I'll just keep it in terms of v and y. Root of u square by, right, Utsa, you got it. So this, when you integrate, this will be v square by 2. Limits will go from u to v. This will be minus g naught y square by 2. Limits will go from 0 to y. The 2 goes off. This will be v square minus u square is equal to minus g naught y square. Shaunak, you're saying something. So this gives you v is equal to root over u square minus g naught y square. This is your velocity or the speed as function of height. Now what do you want to find? At h max, so when you reach the maximum height, your speed is 0. And the y coordinate becomes h max. That is still valid. That has nothing to do with gravity. Whenever you're about to take a turn, your velocity becomes instantaneously 0. So if you substitute the formula here, you end up with 0 is equal to u square minus g naught h max square. So from here, we got h max is equal to u by root g naught. Check. That is your h max. So you just have to go back to the basics. Integration a is v dv by dy, and then you just integrate. So when you're reaching the maximum height, your speed will be 0. Question still not over. What about the time of ascent? How do you find the time of ascent? Time of ascent, nahi re Ramek. That's not the answer. It's a little complex. You have to go back to the integration again. So story is still the same. So I know v is equal to root over u square minus g naught y square. Let me show it in the next page. So this is your h max. Any doubts on this page? So we know velocity is root over u square g naught minus y square. This can be written as dy by dt. This is root over u square minus g naught y square. Bring it down, dy by root over. I will arrange this a bit. I can write this thing as u by root g naught ka square minus y square. And I'll take out a root g naught common. Let me write it here only. See, you'll see why I'm doing this. If you take out root g naught common, you will end up with root over u by root g naught ka square minus g naught minus y square. Because in max, right, there is a formula we derived. We're going to get this form. So root over integral dx a square minus x square ka integral is 1 sine inverse x by a. This we have done in calculus, integration by substitution, the second one. Remember this? This is the integration you're going to get. So you need to remember the 4 integrations I taught you. This one, this one, this one, and this one. So page 151, you can refer this. I'll just put it down. For page 151 calculus. So we're going to get it in this form. So I'm trying to put it in that way. So this will be dy by root over u by root g naught ka square minus y square is root g naught dt. Integrate on both sides. Now look at this thing. This guy is looking like a and this is looking like x, isn't it? If you look at the comparison, the integration, they look like that. What are the limits? This will go from 0 to time of ascent. This will go from 0 to h max because you want to find time of ascent. So the formula is sine inverse x by a. Sine inverse x का place में you got y and a का place में you got u by root g naught. Limits will go from 0 to h max. This will be root g naught t. So we get time of ascent is equal to 1 by root g naught. If you substitute the values there, sine inverse, but what is h max? H max is again u by root g naught. You actually get sine inverse 1 minus sine inverse 0. Sine inverse 1 is what? 90 degrees. So this is 1 by root g naught pi by 2. That is 0. This is your time of ascent, everyone. Sine 90 is 1, so 90 is sine inverse 1. Clear with this? So the thing is, see, if you have written till here, I think physics part is done. The rest, what follows after this is pure max, so that is okay. In case you had a trouble with this integration, that is okay. You should have realized at least, that you could have done till here. If you reach till here, I think you got the question. The max part, don't worry about it. When they actually teach you integration, this is a very simple integration. You will laugh at this, but now it looks deadly. But in 12, this will be a joke. So I'm more concerned about till here. If you got till here, your job's done. Yeah.
Sir, can you please explain what you did by taking the root g naught common while rearranging?
Just look at this thing. Now, this is a square minus x square. This thing, there is a g naught sitting here. I just want pure y square there.
Yes, sir.
So I just took out g naught outside. Then this became, see now, this thing looks like a square minus x square ka term.
Yeah, sir, I got that, but like, how did that root g naught come outside?
Think about it. You guys
Okay,
are
so
max
you go
experts.
inside
You
and
just
you
don't
get
know a
g.
root.
Okay,
Yeah.
I got it.
Seriously, इतना बड़ा integration समझ में आ रहा है, but root g naught समझ में नहीं आया. Check it out anyways. But any other doubts, please ask. This is a complex one. You guys should definitely tomorrow take a paper and resolve the whole question again.
Can
You
we
might
just go to previous slide?
previous page. Have a look at the page, everyone. Anything that you're not clear, please ask. Advanced my questions will be like this. You should, meaning integration and differentiation are like pretty common, like it's pretty normal there. But like I said, don't worry about the integration part. I'm more concerned about getting till here. Any doubts on this page? Hmax was still fine, manageable. It's not a very big integration, but yeah, time of flight, time of ascent was a messed up thing. All clear with this? So I have a small doubt here. Is time of ascent and time of descent same? Think about that and let me know if you got something. Think about that. Clear? There. So these are few questions, where you're throwing things from the bottom. So what happens if you throw from buildings? Let's see the next one. This is a standard result. You should definitely remember this. Exam like BITS or CET, Manipal, Vellore, all these exams, it does pop up. Let's say we got a building of height h. In the first case, you took a particle, you released it from rest. So this particle fell straight down and let the time of flight be t1. Second question, you projected vertically up with speed u. So this thing went up and then came down. The third one, you projected down with speed u, same speed, this thing came straight down. Three possibilities see, either you leave the particle or you throw up or you throw down. For now, we are still doing 1D. Later on, we will throw horizontally also, but for now, this is the thing. This time of flight is t2. This time of flight is t3. There, if you leave the particle, time of flight is t1. If you throw the particle up, time of flight is t2. Remember, time of flight is the time taken to reach the ground here. So find the relation between t1, t2, and t3. So find t1, find t2, and find t3, and then find the relation between them. That relation is important. Matlab, it's a standard result. Hope the question was clear. The first particle is released from rest. Second one is thrown up with you. The third one is thrown down with you. Near Shreyans, that's not the answer. Just think about it. Your dimensions are also not matching, right? Left may have time square and right side you have a time. So dimensions are not working out. I hope the question was clear. Someone is not clear with the question, please ask me. I'll explain again. I know the answer is a little difficult to type, but you can get me the relation. That is easy to type. Yeah, that's not the relation. You get a pretty neat relation between them. What you found is fair enough, but I'm not asking that. There is a thing. You can relate T1, T2, T3. Meaning if I give you T1 and T2, you can find T3 का value. ऐसा.
Oh, like that.
First, let's find T1, T2, T3 normally. Let's see how to do that. Take a minute, then I'll show you. Again, remember, all you have is the three equations. Just because you're throwing from buildings doesn't mean your equations will get messed up. You can still use S is ut plus half at square. नहीं रे Siddesh, how is that even possible? Think. Throwing up and throwing down, how can they be same? Definitely, right? We know throwing down will actually reach faster. Should I help you? नहीं रे
2
उत्साह,
minutes.
that is not the answer. 2 minutes इतना नहीं मिलेगा. I'll give 1 more minute.
So 30 seconds.
ये देख, bargain कर रहे. This is a good one. So when you throw from building, this will be the first idea. And whatever we're doing here, these are the basics. When we do projectile, you will need all this stuff again. Shriyansh, you got it. Yeah, one answer. See, listen to this thing. नहीं हो गया. नहीं रे Ashman. That's what I told. That's not what I want. Listen, everyone. So always keep this in mind. The point where you're throwing from is always the origin. Okay? That the starting point is always your origin. So if you're throwing like this particle is coming down. So the displacement is which way? Down, isn't it? So what is the displacement here? S is equal to minus h. Agreed? What is the displacement in the second case? Again, remember the
Minus
meaning of
h.
displacement. Initial to final. I don't care whether you throw up or you throw down or you do anything you want. This is the initial point. This is the final point. So second case, the displacement is minus h. Are you getting this? I didn't ask distance, displacement. What is the displacement in the third case? Minus h. In all the three cases, the displacement is minus h. Whether you throw up, you leave it, you throw down, the displacement is minus h. Then using the equation, S is equal to ut plus half at square. So what changes in all the three equations is the speed. So in the first question, S is minus h, speed is 0, gravity is minus g, so half g t1 square. So we get t1 is root 2g h by g. This is another standard result. Whenever you drop a particle from rest, this is the time of flight. Look at the second one. S is minus h. You're throwing up, so positive ut2 minus half g t2 square. That's it. You always put it in the equation. You just need to check what is S and U and everything. So this will be half g2t square minus ut2 plus h is equal to 0, quadratic. Find the roots for this. You will get t2 is equal to u plus minus you will not take. It will be greater. This will be root over u square minus, I think that will be minus h only. Yeah, you go that side, yeah. Plus 4g, so that will be 2gh by g. What about the third equation? S is minus h, u will be minus. That is the catch. So in all three equations, if you see, what makes the difference is the u ka, u ka sign. This is 0, this is plus u, this is minus u. All three cases, the displacement is same. So if you look at this equation here, this will be half gt3 square. This will be plus ut3 minus h is equal to 0. So this time of flight will be t3 will be minus u plus root over u square plus 2gh by g. Check everyone. These are your time of flight. And you can clearly see here, if you multiply T2 and T3, it looks like A plus B and A minus B. You'll get T2 into T3. This will come out to be T1 square. That's the relation between T1, T2, and T3.
So these guys
You
are in
can,
GP.
yeah, you can say. So if you multiply T2 and T3, you'll get this guy, which is T1 square. That's a standard result. You should definitely mug it up. If it is an exam like mains or bits, you won't have time to derive this. Check it out. Now, see, more than the result, right? Remember how I derived each of them. So it doesn't matter if I throw up or down. The displacement is minus h. And we are still using the same equation, s is ut plus half at square. So the thing that changes is your speed. Any doubts on this? All clear with this? Great. Let's see a question. Can I turn the page? Next one. This is another standard model, 27. We have a tall building. I think it's a very, big height. And you took a particle from here and you released it from rest. Right? The first question, find the ratio of distance traveled in 1 second, in 2 seconds, in 3 seconds, and so on. Second question, find ratio of distance traveled in first second, second second. Now this is different. Third second, and so on. Third question, find the ratio of time to cover first 1 meter, second meter, third meter, and so on. What is the meaning of third one? See, first meter meaning this is 0, this is 1 meter ka mark, this is 2 meter ka mark, this is 3 meter ka mark. So I am asking you, how much time did you take to cover 0 to 1? Let the time be t1. 1 to 2, time is t2. 2 to 3, time is t3. I want t1 is to t2 is to t3 is to t4. Are you getting what I'm asking the third question? Find the ratio of time taken to cover first meter, 0 to 1, 1 to 2, 2 to 3. The distance ka time I want. And let's get the three questions, everyone. Yeah, right. Okay. Yeah. Standard one. Let's get this. Why logical? It's a mathematical function is t square, right? S is half gt square. So t square function. So obviously it will be n square function only, right? Yeah. So you have to explain it mathematically only. Right, Samya. Yeah, first one is easy. Get the third one. I'm more interested on third one ka answer. 1 and 2 are fine. You will get it. That is easy. Give me the answer for third one. Aditi, what did you do? No, that's not. I think you wanted to type 149, yeah? Or you typed 129. Check. Right, Siddesh. Right, Shreyansh. Let's get the third answer. Third answer. I want the third one ka answer. C is the one I'm more keen on. Everyone should try to type an answer. Param, answers. Srihari, answers. Nahi aa rahi hai. That is wrong. Devanshi, answers. Yashvi. You're right, Param. A and B are right. Get me the C part. Right, Obia. We have one answer. Sidesh. Yep. We have one more answer. Yeah, right. Nay, Ishman. You got it. I think you forgot to do something there. Let's see the first two parts. So you want to find the ratio of distance traveled in 1 second, 2 seconds, 3 seconds. Fair enough. So what is the equation? S is equal to ut plus half at square. You're dropping from rest, so your initial velocity is 0. Gravity is simply half gt square. So minus sign, but it is coming down. So in 1 second, you will travel how much? So remember, this is t is equal to 0. So 1 second, you will go half g1 square. That is t is equal to 1. In 2 seconds, you will go how much? Half g2 square. In 3 seconds, you will go half g3 square. You can see the sequence. So the first question, the answer would be half g1 square is to half g2 square is to half g3 square, and so on. So this will be 1 is to 2 square is to 3 square is to so on. What about the second part? You're asking for the first second. So remember, what is the first second? First second is 0 to 1. What is second second? I'm asking from here to here. This is the second between 2 and 1. And this is the third second between 3 and 2. So the second answer, for the first second, you're traveling half g1 square. For the second second, you're traveling half g2 square minus 1 square. And for the third second, it will be half g3 square minus 2 square, and so on. So if I get the ratio here, this will be 1 is 2, that is 3 is 2, and 5 is 2, and 7, and so on. Clear with this? You just subtract the distances between 2 and 1, then you'll get the first, second, 3 and 2, and so on. What about the third one? Right, Utsav. Look at the third one. So if you're dropping a particle from here, u is equal to 0, right? Look at the time of flight here. We have s is equal to, you can ut plus half at square. So this will be minus h, your falling height, 0 minus half gt square. We derived it. This is the first case. So we get time is equal to root 2 h by g. Now what are you asking? For the first meter. So from 0 to 1, this is the first meter. The time taken will be root over 2 times 1 by g. That's for the first meter. For 2 meters, the time will be root over 2 times 2 by g. For 3 meters, the time will be root over 2 times 3 by g. Now you're asking time for first meter, second meter. So second meter meaning I need to subtract these 2 times. So for the third one, the answer would be root over 2 times 1 by g ratio, root over 2 times 2 by g minus root over 2 times 1 by g. Are you getting what I'm doing? I'm finding time for the first meter. I'm finding time for 2 meters. When I subtract, I'll get 1 and 2 cut time. This will be root over 3 by g minus root over 2 times 2 by g. And so on. The 2 by g goes off. You will get a very neat sequence. Root 2 minus 1, root 3 minus root 2, root 4 minus root 3, So, and so on. The sequence goes like this. Actually, you can write 1 also like this. Root 1 minus 0 and root 2 minus root 1. There you can see a sequence. Clear with this? The C is a decent one. So, yeah, this would be like maybe a CET level questions, but C is still a good one. Mains when they might ask you 2-3 statements at the same time. Any doubts on this? All clear with this? There. So that's a bit about it. So we have seen a lot of different models here, especially this integration part. So do make sure to check this out. That will be the last one for that day. So next class when we catch up, we'll continue from here. We will see fewer models on this thing. We will use more calculus-based problems. We'll check it out, right? And then I think mostly next class we might even start off an intro with the projectile also. So okay, with that we'll wrap up for that day. And I hope everyone has given the test. There's a test online till today night. In case you have not given, it is still online. So you can give it before 11:30. So you can give it. Meaning if you log in at 11 o'clock also, you'll still get 1 hour of time. So I'm telling you that thing. So if you open the test at 11:29 also, you'll get 1 hour. But I think test is only online till 11 o'clock. So make sure to give it started before 11 o'clock. So in case someone has not given the test, please make sure to give it. Okay, with that we'll wrap up for the day. So we have almost done 27 questions. So do make sure to go through them. So any doubts, anything else, you can stay back and or else you're free to leave.